On to the final problem of the DGD. This is 6.52, and we have this can with benzene inside of it. So the can is at a certain pressure, and it's going to be releasing benzene into the air, straight up into the air. Now what we're first going to want to do is draw the streamline, so from point 1 to point 2 right there, and then write down Bernoulli's equation. Now Bernoulli's equation again is P1 plus 1/2 rho V1 squared plus rho G H1 or Z1 is equal to P2 plus 1/2 rho V2 squared plus rho G Z2. Now if we look at our streamline plot right here, from at point 1, we don't have any velocity and we don't have a variation in height, as we're going to take that height as being 0, which means V1 and Z1 are going to be 0. Additionally, along the streamline, at point 2, when we reach the height of where the benzene is going to shoot up into the air, our velocity of that benzene is going to be 0, so V2 is going to be 0. Now additionally, one important factor is that we're assuming atmospheric pressure everywhere. So P1 would technically be P1 gauge plus atmospheric, and then at point 2 along the streamline, would only be atmospheric pressure, as the benzene would be at atmospheric pressure. And so for this reason, what we're going to say is that P2 is going to be equal to 0, and P1 in this case is going to be gauge. This gives us our final expression, which is just P1 is equal to rho G Z. Now looking in the tables in the back of the textbook, we could find the specific gravity for benzene, which is going to be 0.879. This means we could find the height, so Z2 would be equal to P1 over the specific gravity times the density of water times gravity. And now that we have all the variables, we could find the height of the benzene, so 50 kPa divided by 0.79 times the density of water times gravity, and this gives us, keep in mind that kPa's is going to have to be converted into pascals if we're all using standard units, and what we get is 5.8 meters.